Before running off to build a network, you'll need to know what equipment is required, and how that equipment functions in a network. This section of the module will discuss the equipment that is required to construct a basic home network. The objective of most modern-day networks is to enable access to the internet to multiple devices. I'm not sure if you noticed or not, but in the types of networks section, none of those diagrams illustrated a connection to the outside world. Networks can operate independently of a connection to the web. As a matter of fact, a network can consist of a connection between only two devices. If the goal of your network is to be able to surf the web, you're going to need a modem. Modems function as negotiation points between your home network and the wide area network known as the internet. That's the reason you'll hear geeks sometimes call it a gateway. Your home network is walled off from the outside world, and adding a modem is like adding a gate to the wall so information can pass back and forth. The wall I'm speaking about isn't metaphorical at all. It's called a firewall. A firewall protects against intruders and unwanted access to your network. The gateway opens to let information pass through from pre-approved sources, and blocks any requests from unknown sources. Your home modem is typically included with your internet service. They'll charge you for it, but you'll get one. If you want to find out more about how to stop renting your modem and save that $120 per year, click the blue info button below the bullet points. If not, click the green continue button to move on. The role of a router differs from the role of a modem in a number of ways. Because of the recent trend of combining routers and modems into a single device, there's some confusion about what routers do in a network. Modems are designed to create a connection to the internet, while routers are designed to share this connection with multiple devices. Keeping with our highway traffic metaphor, a network without a router is like a highway without off-ramps. It's simply a road from point A to B, but routers create off-ramps and road signs on that freeway so information knows where it's going. Instead of information traveling to a single location, it can now be routed to multiple locations. Thus, a router's job is reflective of its name. It routes traffic to the appropriate location on a network. To be able to perform this function effectively, the device has to have some processing built in. The chip inside a router reads the incoming and outgoing information and sends it to the proper location. How does the router know the location? It has the address. In the IT world, these addresses are referred to as IP addresses, and the router creates, assigns, and memorizes these locations. It's the brains of the network. The efficiency of a router is determined by a couple of different features that I'll discuss in the last module of this course, but right now, I want to take a second to address router-modem combinations. To reduce the number of networking devices in a home, consumers can now rent or purchase a router-modem combination device. These devices provide the function of a gateway to the internet, as well as a connection point for multiple devices. You may be asking yourself, is there any disadvantage to combining these devices? The answer to that question is kind of. Devices always function better when they only perform a single function. Whenever you combine two devices into one, you have to ask yourself two questions. 1. Is the performance of either component being compromised? In the case of a modem-router combination, it's not, but matching the performance of two standalone high-end devices with a single combination unit will be quite expensive. Which brings me to my second question. 2. If one element of the combination device breaks, will I have to replace both of them? That answer is yes. If the router or modem function stop operating for some reason, you're going to have to go all in on a big price point replacement. It's just something to consider before you go this route. No pun intended. With all the talk about routers' core functions, I almost forgot about what has made routers so popular in modern-day network installations. Routers enable multiple devices to connect to a network, but they aren't the only devices that do that. We'll get into hubs and switches in a second. What makes routers so special is their ability to offer these connections to devices wirelessly. Routers create Wi-Fi connections and allow laptops, cell phones, and tablets to maintain a network connection while being mobile at the same time. So you may be wondering what other devices are available to help you construct a home network, and this section provides the last pieces of that puzzle. Before the Wi-Fi craze, the only way to connect additional devices to a network was through hubs and switches. I explained routers before we started this section because if you can understand what function a router performs, you can definitely comprehend what switches and hubs do. I'll address the devices in descending order of intelligence to make this as easy as possible. If you think about everything a router does, including create, assign, and memorize addresses, then you'll only need to remove the ability to connect wirelessly to figure out what a switch does. A switch performs in an identical manner as a router, minus the wireless signals. In the early days of networking, wireless signals were either not invented or not reliable enough to connect multiple devices, so every device required a wire back to a central switch. Before there were switches, there were networking hubs, and they look identical to switches, so I'm not going to throw an additional graphic on screen to represent them. When I said I was going to address the devices in descending order of intelligence, I wasn't kidding, and hubs are the least intelligent of all the networking devices. Imagine that we took the processing chip out of a switch, and then you'll understand how a hub works. The processing chip is what assigns and remembers network addresses. So without one, a hub is forced to send the information to every port because it doesn't know where any particular device is connected. It essentially functions as a signal repeater instead of doing any routing or switching functions. Metaphorically, we just removed the road signs from our highway. At one time, the processing chip made the jump from a hub to a switch expensive for the average consumer, so many opted for hubs as an inexpensive way to connect multiple devices to a network. The information will still get to its final destination, it's just an inefficient way to get there. As the price of chips has declined over the years, hubs have pretty much disappeared from the networking world, and any device purchased today is actually a switch. Using a combination of modems, routers, and switches has enabled consumers to build networks that were once reserved for business entities. Now that you've acquired the knowledge you need to build a network, let's get to some specifics. This course will explain the information you need to make all the right decisions regarding setting up a home network. The information will include the latest technologies for wired and wireless networking solutions. In the Wired Networking Solutions module, we'll take an in-depth look at the connections, speeds, and installation considerations for networking with Ethernet, coax, and power lines. In the Wireless Solutions module, we'll take a look at connections, speeds, and installation considerations for Wi-Fi, Wi-Fi Direct, and Bluetooth solutions. We'll end the course with instruction on how to lay out the design for your home network, and then you'll be free to start poking holes in walls.